Okay, example. Now take a look at examples. Median in a group data. Okay, now the following table presents the number of text messages sent via cell phone by a sample of 50 high school students. Okay, approximate the median number of message sent. So now from the table here, we make a class for the respective frequency. Okay, from the ungroup data, we group the data by using class. Okay, so formula for the median class must be at least n over 2, which means that median class falls into data which is greater than 25. 25 is a cumulative frequency. Cumulative frequency means that we need to sum up 10, 5, 50, 13, 11 and so on. So now when we sum up 10, 5 is 15, 15, 13 is 28. So 28 greater than 25, so meaning that 28 is the class, median class. Median class is 100 until 146, 149. Okay, so formula for median is LM. LM is the lower class. Okay, lower class size, meaning that the boundary of the lower class size is 99 plus 100 divided by 2, so we have 99.5 as a lower class size for median, and then plus plus n over 2. So plus n over 2, 20, which is 25, minus 15. 15 is the cumulative frequency before the median class. So which means 10 plus 5, 15. Okay, over frequency at the median class. So frequency at the median class is 13, and then plus, and then multiply by n. N is 50. So calculate this. The median for this group data is 137.96. Okay, if we were to approximate median using ogive, okay, from ogive that we plot on the coordinate y and x axis, so we refer to the median formula. N size over 2 is 25. Okay, so now 25 is on the y-axis. Now refer the respective value on the x-axis for 25. So if we refer to the x-axis, the value will fall on 140. So this is the median of the group data using ogive. Okay, mode of a data is the value that appears most frequently. So meaning that kalau data tu appear banyak-banyak kali, paling frequent sekali, so that will be the mode of the data. Okay, it is sometimes classified as a measure of center. However, this isn't really accurate. The mode can be the largest value in a data set or the smallest or anywhere in between. If two or more values are tied for the most frequent, they are all considered to be modes. Kalau kita ada banyak data yang value yang appear sama banyak, sama frequent, so mode tu boleh jadi lebih daripada satu. Okay, as long as data tu yang paling banyak sekali appear dalam sampling ataupun population. Okay, it is no value if no value appears then more than one, we say that the data set has no mode. So sampel kita juga boleh jadi tak ada mode. Okay. Cool. So this is type of mode. It is said the mode is said to be not unique. Because it has many properties, many many types of modes. Okay, so it is not unique. Okay, the mode is the data is said to be no mode if a data set with each value occurring only once. Kalau mode tu appear sekali saja, so maknanya kita tengok semua data tu unik semua ada appear frekuensi dia sekali saja, so we say that the data has no mode. Unimodal if a data set with only one value occurring with the highest frequency. Okay, so nanti ini number 5. Okay, number 5 appear 2 kali. So satu saya data yang appear 2 kali. So we say the set of data or samples are unimodal. Okay, bimodal if a data set with 2 values that occur with same or highest frequency. So macam ni number 3 dengan number 5 tu appear sama banyak 3 kali. So dua data appear banyak kali. So we say it is bimodal. Okay, multimodal if more than 2 values in a data set occur with the same frequency. So kalau banyak data more than 2 yang appear sama banyak, we say the data has multimodal mode. Okay, procedure of computing mode. Okay, for ungrouped data, so this is easy. We can only find mode for ungrouped data for value that occurs most frequent. Okay, so it could be more than one value. Okay, for group data, so we need to determine the class mode of the class with the higher frequency using the formula of LMO plus delta 1 over delta 1 plus delta 2 times I, where I is the class wide and delta I is the difference between the frequency of class mode and the frequency of the class before the class mode. So this is the difference actually. Delta I is actually the delta 1 is the difference between. So at first we need to identify where is the class mode, and delta I will be the difference between frequency of the class before the class mode and frequency of class mode. Okay, delta 2 is the difference between the frequency of class mode and the frequency of the class after the class mode. For delta 1 class mode and before the class mode, and delta 2 is the different frequency of the class mode and after the frequency of class after the class mode. And LMO is the lower boundary of the class mode. So by using this formula, okay, so we need to identify one by one what are the parameters. So these are the parameters that we need to determine from the group data. So by using this formula, we find the mode of the group data. Okay, example 5, mode for ungrouped data. 10 students were asked how many siblings they had. The results arranged in order were as given. Now find the mode of this data set. Okay, so now we arrange the data. Okay, now we arrange data in order. So we will have something like this. 2, 2, 5, 5, 8, 8. Okay, so this is not. Find the mode of this data. Okay, mode of this data is 1 because number 1 appear the most. Okay, okay, for this data, 2, 2, 5, 5, 8, 8, 10, 10, 15, 15. So we have mode will be number 2, number 5, number 8, number 10 and number 15, since this data appear 2 times, okay, equally. They appear 2 times equally. So number 2, 5, 8, 10 and 15 are mode for this ungrouped data. Okay, example 6, finding mode for group data. The following table presents the number of text messages sent via cell phone by a sample of 50 high school students. Now approximate the mode number of messages sent. So this is the class for this group data and the respective frequency. Now using the formula as given in the earlier slide, the mode is given by, so mode class fall in this the highest frequency. So this is the mode class. Okay, the lowest lower bound for this class is 99.5 from here. Okay, and then using the formula, delta 1 minus delta 2, so 13 minus the mode, this is the delta for mode class 13 minus delta 1 is 5, and then it is the 1, and then 13 minus delta 2. Okay, the next frequency. Okay, and then multiply by n. So the answer is 121.72. Okay, if we use histogram, we are able to see the mode by looking at the most frequent data. Okay, from frequency here, so we can see the most frequent data falls on this value. So we can refer to graph by looking at the most highest frequency on the y-axis. Okay, so this will be the mode of the data using histogram. Okay, but using histogram, we are not able to find the exact value on the x-axis because the histogram or the picture was displayed using class size. Okay. So to find the mode using histogram, so we need to draw using the point to point. So we need this is the mode. Okay, the mode histogram, and then by drawing a line from the top on one side to another side, from here to here. Okay, top tu means that dia punya lower boundary dengan upper boundary. Okay, so from here connect to the previous punya top, and here top here connect to the following punya histogram top. So in between yang cross ni adalah refer to the x-axis, adalah value kat sini will be the mode of the group data. Okay, now properties of mean, median and mode. The mean and median can only be computed for quantitative data. Okay, remember that. Untuk mean dengan median, it can only be computed for quantitative data only. Okay, but the mode on the other hand can be computed for quantitative data and qualitative data. For qualitative data, the mode is the most frequently appearing category. Okay, for qualitative data yang paling banyak appear. Okay, example following is a list of the makes of all the cars rented by an automobile rental company on a particular day. Which make of car is the mode? So kalau tengok yang mana model kereta yang appear paling banyak sekali, that will be the mode of the data. So dalam case ni Toyota appear most frequent. So therefore the mode is Toyota. Okay, the median is resistant but the mean is not. So what does resistant mean? A statistic is resistant. Statistic mean median atau mean. That is called statistic. A statistic is resistant if its value is not affected much by extreme values, which mean extreme values large ataupun small in the data set. So data affect so much by data yang ada data dalam set of data tu value dia sangat ekstrim. Contohnya ada nilai yang paling kecil dan antara nilai yang paling besar. So median ni resistant sebab nilai dia tak efek banyak sebab kita susun ikut ascending order kan, di tengah-tengah tu. Tapi kalau mean tu dia akan efek banyak. Sebab range tu kita tambahkan semua, ini divide by number of data, so dia akan effect banyak. So dalam kes ni median is resistant. Okay, example of resistance. Now, 5 families named Smith, John, Gonzalez, Brown and Jackson live in an apartment building. Their annual incomes in dollars are given. The Smith family, whose income is 25,000, wins $1 million lottery. So their income increases to 1,025,000. Find the mean and median income both and after the Smith win the lottery. Which measure of the center is more influenced by the large number? Either the mean or the median. Okey, dalam kes data yang ni, mean untuk kes yang data yang ni, okey, mean adalah 38,000 and median is 34,000. Okey, so kalau data yang baru, okey, kita dapat extreme data kan, 1 million is added dalam kes ni. So mean akan jadi 238,000 and median tak lari banyak daripada median sebelum tu, 44,000. Tapi mean akan jadi, pengiraan mean akan jadi berbeza jauh daripada mean yang sebelum ni. So that's why mean is not resistant and median is resistant. Okay, now we want to describe the shape of a data set. Okay, earlier we have learned about distribution which is symmetric and distribution which is skewed to the right and skewed to the left. Okay, now for mean and median, measure the center of data set in different ways. So when data is symmetric, mean and median are equal. So kalau data tu sama je, dia punya symmetrical tu sama je, balance left and right, so mean and median are equal. Okay, but when data is skewed to the right, large values in the right tail. Kalau skewed to the right, makna data lebih besar ke arah kanan. So because the median is resistant while the mean is not. The mean is generally more affected by these large values. Therefore, for data set that is skewed to the right, the mean is often greater than the median. Okay, for distribution which is skewed to the right, mean greater than median. Similarly, when data skewed to the left, mean is often less than the median. So it depends on the shape of the data. Either it is skewed to the right or skewed to the left. Okay, as given by this graph, where we have the shape, it is skewed to the right. Skewed to the right, it means that median and mean will be at about the center. So therefore, we can see that mean is normally greater than the median. Okay, this is a common situation for distribution shape skewed to the right. Okay, for distribution which shape is skewed to the left, so we can see that mean is noticeably less than median. Mean will be nearer or closer to the area where the shape of distribution is skewed to the left. So mean is less than median. Okay, for a symmetric distribution shape, so we have a proportion shape of graph. Median and mean are equal. So both parameter mean and median are equal. They are at the center of the distribution. Okay, for this example, following situation determine the shape of distribution. Okay, for mean value 10, median 15 and mode 20. Now try to determine the shape of the distributions. So we can see since mean is less than median, so it is left skewed. Okay, mean 15, median 15, so both are equal, so the shape are symmetry. For mean 15 and median 10, so meaning that mean greater than median, so the shape of distribution is right skewed. And then for mean 10.1 and median 10.32, it is approximately symmetry because it's close to each other, mean and median. Okay, for mean 8 and median 15, it is less skewed since mean is less than median. And for mean 11 and median 12, it is approximately symmetric because the mode is 12. Okay, mode is 12. Okay, and median is 12 and mean is 11. So we can see they are about the symmetrical. They are about symmetrical. Okay, so this is the difference characteristic between mean, median, and mode. So of these three parameter, uh, one have advantage over another parameters. So for researcher, normally they will select which one is the most appropriate parameter to be used for estimation. Okay, for parameter estimation in the sampling or in the populations. So it depends on how the researcher want to select the parameter, either to go for mean, median, or mode. It depends on the difference between these three parameters. So these are the difference between the three parameters. The advantage of mean is it is unique. You consider all data set during the mean calculation. And median also the advantage, it is unique and it is resistant to outlier. And for mode, it can be used to calculate qualitative and quantitative data. So this is the advantage of each of the parameter. Okay, the disadvantage of each of the parameter is, for mean, it is sensitive to extreme value. Okay, the one that we have described earlier. For skewed to the left or skewed to the right, mean is very sensitive. So it is not resistant compared to median. Okay, disadvantage of median, it is difficult to handle by theoretical. And for mode, the disadvantage, it is not unique. And some of the data set doesn't have mode value. Okay, okay. For mean, the interpretation of the mean, it is the center of the gravity. Interpretation for median, it is divide the bottom 50% of the data from the top 50%. So meaning that the data is organized in ascending or descending. So the one in the center, the middle part by sequence is the median. So it is divide half half. Okay, the one in the median of the arrangement is the median. Okay, mode is the most frequent observation. So this is how we interpret mean, median, and mode. Okay, for when to use characteristic for mean. So when do we use mean? When the data are quantitative and the frequency distribution is roughly symmetric. Okay, when to use median? When the frequency distribution is skewed to left or right. Okay, okay. Symmetric, skewed. Okay, for mode, what about mode? When do we use mode? When the most frequent observation is the desired measure of central tendency of the data are qualitative. Okay, for qualitative data, the most preferable parameter for use is mode. Okay, and for quantitative, we go for mean and median. Okay. And also for mode, we go for mode when the most frequent observation is the central tendency, the one which is very important in the study. Okay, example, the selection of the parameter is either mean, mode, or median. Okay, select an appropriate measure of center, either mean, median, or mode for following situation. A student takes 4 exams in a biology class. His grades are 88, 75, 95, and 100. So this is almost symmetrical. So we use mean. The National Association of Realtors publishes data on resale price of US homes. So this is is it quantitative or qualitative? Publishes data on resale price of US homes. So resale price meaning that we can arrange in a ascending or descending order. Okay, so it has a pattern. Once it has a pattern, we can use median. Okay, for the marathon had two categories of official finishers, male and female, of which there were 10894 and 65 and 55 respectively. Two categories, if there were. Okay, so for this case, okay, why it is considered as mode? Okay, why this data we need to consider as mode? So please think why for this type of examples we use mode as a parameter instead of mean or and median. So we refer to the advantage and disadvantages of mode.